You may have sunglasses that are polarized. Polarized glasses are designed so that they reduce glare. A lot of times, the glare coming off of glass or water is it's polarized light. That means that all of the electric fields in the light are aligned along a single plane. We'll learn more about light later, but keep in mind glare is often polarized light, like when you see glare coming off of a window or uh, a body of water that's often polarized. So our polarized sunglasses filter them out. Engineers can actually use polarized light to help them identify areas of stress in their designs. Here we see a model of a bridge. An engineer, or more likely a group of engineers, designed this bridge and then built a model of it. This is not the actual bridge. They built a model of it out of materials that reflect polarized light. So they shine the polarized light on it and they can see the patterns of color that appear. Where we see these broad areas where there are no changes in color, those are areas of low stress. Where you see the stripes of varying color, those are areas of higher stress. And by doing this kind of analysis, engineers can identify where there might be areas of stress on a design, and then they can adjust the design in their next iteration to account for those areas of stress. Here we see a tape dispenser. In this image, we see polarized light coming through or reflecting off of a transparent object. And we can see that there are these broad flat areas where there's very little stress. And then we can see the areas where the stripes, the multicolored stripes form. Those are areas of high stress. So you can use polarized light to find areas, and that will help you predict where the structure will fail. The many different colored stripes in these two areas that are indicated by the arrows suggest a considerable strain on the material at these points. These are likely points of failure. If handled roughly, this is where the dispenser is most likely to break. This kind of analysis can help designers make adjustments to their next version or their next iteration of design to reinforce or eliminate those weak points. What can they do? They can either add material or they can redesign the shape or the manufacturing process so that we see less stress at these points. On a tape dispenser, maybe it's not a big issue. Maybe it can withstand, even in those high stress areas, maybe can withstand the forces that are going to be applied to it. On a bridge, on the other hand, you really need to be careful about where it is strong and where it